Hello and welcome to helpyourmath.com. In this video, we are going to look at the law of large numbers again. This time, we're going to be rolling 2 dice. If you have dice handy, you can actually do the experiment at your leisure, or you can find a website that will roll 2 dice for you a number of times, or I'm going to use Microsoft Excel to roll 2 dice. Just a reminder from the previous video, the law of large numbers says that in the long run, as the sample size increases, the relative frequencies of outcomes get closer and closer to their theoretical or actual probability value. And that's what we're going to look at in this video, but with 2 dice. In the last video, we looked at just 1 die. Now we're going to be looking at 2 dice. All right, when we roll 2 dice, there are certain outcomes that can happen. We're going to complete the sample space. A sample space is a list of all possible outcomes. That is, I can roll a 1 and a 1, a 2 and a 1, a 1 and a 2, etc. Note that rolling first a 1, then a 2 is counted differently than rolling a 2 first and then a 1. I'm going to set this up here, but I actually have it all completed on the next slide. The gray is just to put what could happen. So we could roll a 1 on die 1, a 2, a 3, a 4, a 5, or a 6. And die 2, we could roll a 1, a 2, a 3, a 4, a 5, or a 6. When I write the ordered pairs, you'll notice I'm doing the row and then the column. So I'm writing this, the first one, die 1 was a 1, and die 2 shows a 4. Die 1 shows a 1, die 2 shows a 5, and so on. We're going to answer a few questions before we get started with our dice rolling experiment. First up, how many possible outcomes are there? So that's the ordered pairs. And if we count, there are 6 rows with 6 entries in each row. That would be 6 times 6, so 36 possible outcomes. And again, this is just saying like every outcome is unique. So like I said earlier, a 1, 2 is going to be different than a 2, 1. When you roll 2 dice, there are 3 ways you could get the sum of a 4. You could roll a 1 on the first die and a 3 on the other, 2 2s, or a 3 on the first and a 1 on the other. How many ways do you see the sum of 5? The nice thing about the sums is they're actually the diagonals. Those 4s would be this diagonal right here, which conveniently actually would go to the 4s if I would extend it. What would make the 5s would be this diagonal here. And that's what I want to record. How many ways can you get a sum of 5? 1, 2, 3, 4 ways. And then it says to list them. I'll list them using like a sample space technique with the brace. And then I'm going to say 4, 1, 3, 2, 2, 3, and 1, 4. Looking at the sample space you created previously, is there any way to get a sum of a 1 when you add the sum of the dice together? No, right? The smallest sum we could get with these 2 dice is a 2. So is it possible? No, it is not possible. I'm going to say we cannot. And that just means the probability of rolling 2 dice and the sum being 1 would be 0. Okay, so now we're going to fill in this table, the ways that we can get the sum. So this is looking here and figuring out the various ways to get the sums. So we see the 4 is done. We have the 1 plus 3, 2 plus 2, and 3 plus 1. And then total possible outcomes, this would be 3 out of 36, which we could write as a fraction in simplest form or a decimal or both. 3 and 36 is 1 in 12, which is approximately 0.083 where the 3 repeats. Okay, so I'm going to fill in this table. You can follow along with me. All right, I'm back. Did you fill out yours? I got mine. Do the probabilities in the table all add up to 1? They should. So let's look at those unsimplified fractions. We have the 0 out of 36, the one I'm going to focus on the numerators because the unsimplified have the same denominator. I can just combine the numerators. 1 plus 2 plus 3 plus 4 adds up to 10. 5 plus 6 is 11. 10 plus 11 is 21. I'm here at this 5. 21 plus 5 is 26. 26 plus 4 is 30. 30 plus 3 is 33. 35, 36. So 36 out of 36 is 1 or 100%. I'm going to say yes. Yay. If you did the rounded decimals, it might add up to like 1.02 or 1.01, and that's fine. That's just rounding error. That's not a problem as long as it's close to 1 or 100%. Based on this, which sum is most likely to occur when you roll 2 dice? Well, which one occurs the most frequency? What would be the mode? And that would be 7. So we're most likely to roll a 7 with 2 dice, 2 six-sided dice. Create a histogram or a bar graph showing the probability for each die result. I want to do this in Microsoft Excel because I find it's very nice. Now we want to create a histogram or a bar graph showing the probability for each of the dice result. I'm going to do this in Microsoft Excel because it'll be a lot neater and faster for me. So I'm going to head over to Excel. I already have it set up where I have the frequency of the sums of 2 dice. I have the sum of the dice, the frequency. What I don't have is the relative frequency. So let me add that, relative frequency. And the relative frequency would be the frequency divided by the total possible outcomes, which is 36. And I can fill this whole thing in by highlighting the one with the formula and then selecting all the ones below it that I want to include. And then I hit Control D. I'm going to make it match what I have. And this is also, I could have done this to check my work when I was filling in my chart. Okay, so this should match what I have in my table in PowerPoint. And now to create this, so what I want to do is I want to just do this first column because I'm doing the frequency. I don't want I'm doing the relative frequency. So I'm going to highlight, I'm hitting Control, and that's going to help me just select those 2 columns, and it's not including my frequency column. Then I'm going to go to Insert, and we have to be very careful. If you expand this, it will demonstrate, oh, that's exactly what I want. There it is. Oh, it's perfection. Well, it's almost perfection. The one thing is that with a histogram, the bars should be touching. So if you double click on one of the bars, you can say you want to have 0 width between them. And that'll get that so we can see it. I might want to add lines so that I can see each one separately. So I'm going to say solid line, and I'm going to make it black. And you can play around with that. You can make it as pretty as you want, but this would be that relative frequency. We see the 7 is the most likely. All right, so now we're going to roll the dice 50 times. And again, if you have 2 dice, you can go ahead and roll them, or you can use a program. I'm going to use Microsoft Excel. Okay, so in Excel, first I'm going to start with the roll number because I want to make sure I'm rolling 50 times. I'm just going to start with 1, and then I'm going to say equals, just to fill in the rest so I don't have to type in 50 numbers. The previous cell plus 1, and I know I'm going to need to go down to 51. And I hit Control D, and there we go, we have the 50 rolls. And now I'm going to go in and do each die separately. If you watch my other video, you know that every time I change anything in Excel, it's going to change the random numbers, and that's okay because we're going to just worry about the very last results we get. To create a random number between 1 and 6, which would be the possible outcomes on a single die, I'm going to say equals random between. I want random between 1 and 6. And I'm going to do the same thing here. I'm going to say equals because that's going to set up the formula. Random between, and I want random between again 1 and 6. Now you might be saying, but wait, couldn't you just do a random number between 2 and 36? And the problem with that is the different numbers have different probabilities, right? The probability of rolling a 2 is different than the probability of rolling a 7. So what I'm doing is I'm creating the probabilities that are all equally likely. Then I'm going to do the sum of them because that should give me the correct variation. If I don't do that, it's not taking in the likelihood of actually rolling a 2 on 2 dice, right? I hope that makes sense. It makes sense in my head. Sometimes that doesn't translate. And what I can do is I can actually do these together. So I'm going to highlight both of them, go down to that 50th cell, do my Control D, and there's those random dice rolls. Now for sum, I just say equals sum, and then I just want the sum of these 2. I just click, hit Shift, and hit the arrow key. And now, and again, it's going to change, and that's okay. I'm not going to worry about that till the bitter end. And we're going to do Control D. There's the sums, right? Everything should be between 2 and 12. If I see a 13 or a 0 or a -4 or a fraction, I'm going to be very concerned. And now, let me create a column here, because we don't, yeah, everything's changing. We don't just want the frequency, we want the frequency of the specific values we can get. So the sums we could possibly get are 2 through 12. So I'm going to just say plus here and just create my 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Control D. There we go. Okay. And now what I'm going to do to figure out the frequency is I'm going to say equals, and I want for it to count. I do count if, because that's going to tell me the exact number of 2s that I find in a cell and the exact number of 3s. So count if. I want the range from this right here, this is D2, all the way down to D51. And I want to know how many 2s there are. There are 4. I don't know the shortcut, as you know from my previous video, so I will just speed through this and count each one separately. Okay, so I finished the frequencies. Now we're going to do the relative frequencies. So I just take the frequency and divide it. Now I've done the frequencies. I want to know the relative frequencies. I rolled the dice 50 times. So I just take each of these numbers and put it over 50. I also just want to make sure it really did count 50. So I'm just going to add these up. I'm going to say sum of these frequencies. It does add up to 50. I feel good about that. Now my relative frequency, I just click that and say divided by 50. And then I can click where the formula is and hit shift and go down and get all of the relative frequencies. And then it asks me to create the histogram. So just like I did for the first one, I will highlight the 2 rows that I want represented on my histogram. So here to not include the frequency, I'm going to hit Control and then highlight this one, and I'll go to Insert, Chart, and it's going to recommend exactly what I want. There it is. Hey, you. Yeah, I'm going to say okay. And I can label it. This is relative frequencies of rolling 2 dice 50 times. And I can add axes in here. So I don't like the fact that I'm not seeing my axes. Sad day. Let's add some axis titles. This one we're going to say is sum of 2 dice. And this one we're going to say is relative frequency. The other thing I don't like is that the bars are so far apart from each other. So I'm going to double click on one of the bars, and that's going to bring that up. And then I can say I don't want any width between them. I want a width of 0. And then I want to make sure that I'm filling in the line between them. So I'm going to do a solid line. I'm going to do black. And there we go. It's beautiful. I'm going to put all of this back into my PowerPoint, and then we're going to compare this to the theoretical histogram. Okay, so I entered everything into my table in PowerPoint, and I uploaded my histogram into PowerPoint. And now we're going to do this again, but this time with 500 rollings of the dice. I will use Excel. You can use something online, whatever you want to do. Okay, I'm here in my new one. I just copied and pasted the one where I rolled it 50 times. And the other thing I can do is I can go ahead and create the relative frequency histogram, and we can watch it every time it changes. It will automatically update, which is really cool. So I'm going to go ahead and do that. Okay, so now I have this thing the way that I like it to be, and we're going to watch this histogram change, although I do need to go and edit because I only have 50. I'm going to keep going so that it's 500. Okay, I have this done. Look at that. I just rolled it 500 times. It already adjusted for me. And now I need to adjust these formulas because this is still only doing the first 50. So I need to adjust this to 501 instead of 51 for each one. And there we go. So there's the 500 rolls. That did not take as long as it should have. And I have everything I need. I'm going to put this in PowerPoint and I'll see you back over there. Okay, so I have everything in PowerPoint. Here I have the frequencies, the probability, and the relative frequencies, and then I just upload the histogram. And then let's look at them all together. The two blue ones, these are my empirical frequencies, my experiments. The one on the right, the green one, that's the theoretical. So what happens as we go from rolling it 50 times to 500 times to the theoretical? Does the law of large numbers agree with this experiment? Yeah, it definitely seems to. It really looks like 500, it's getting closer to that normal distribution. This thing's called a normal distribution or a bell-shaped curve. And we are getting closer to that normal distribution the more we roll the two dice and calculate the sum. This has been an example of the law of large numbers looking at a normal distribution and seeing what happens when we roll two dice 50 times, 500 times, and comparing it to that normal distribution, that theoretical probability. Thank you for stopping by.